Hi everyone, this is an introduction to probability and types of probability. So the first thing we're talking about is independent and dependent events. That means if it's an independent event, you can associate that with replacement. So this is with replacement, it's independent. And dependent, no, this is without this is with replacement, and dependent is without replacement. And we'll go through these 4 examples to go over it. So that's that. We're going to do this problem and 3 others. Some other things you need to know is the fundamental counting principle. So basically it's saying if event M can occur in M ways, followed by N that it can occur in N ways, then you multiply it by M times N. So if there's, you have 3 meals, or say you have a meal, you can choose 3 appetizers, 2 main courses, and say 3 desserts. How many combinations are there? So this is like M ways, N ways, and O ways. So basically you're just multiplying this. 3 times 2 times 3. So that's going to be 9 times 2 is 18 or 16. So that's 18 possible combinations that it can occur. All right. We're also going to talk about the complementary event. And then we already a little bit talked about this. So if they do not affect one another, that means you do replacement. If they're dependent, that means without replacement. And it's written like this and this. So let's look at the first example. A box contains 4 red and 6 yellow tickets. They're randomly selected from the box with replacement. So that means it's independent event. All right. We want to find the probability that both are red. So for that, there's 4 out of 10. If you put all of these in the same box, this is 4 out of 10. But you put the red back in the box and draw again, and your second event would be 4 out of 10. Then you're using your counting principle. This is M ways times N ways for the events. This is really 2/5 times 2/5, which equals 4 divided by 25. Now, do the same thing for the next one. The first one is red, so that's 4 out of 10. Now, the second one is yellow. You put it back, so you still have 10 tickets, but there's 6 out of that. So when you do that, that's going to be 2/5 times 3/5. That gives you 6 divided by 25. Now for B, that's without replacement. That means dependent. Your denominator, when we do this, is going to depend on what we do at the beginning, the first event. So for B, both are red. So the first one is just 4 divided by 10, but you don't put it back. So if you do 4 out of 10, then you only have 9 tickets and only 3 red left. So that would be 12 divided by 90, which is 6 divided by 45, which equals, divide both by 3, 2/15. Now, let's do, the first one is red. So again, that would just be 4 out of 10. Now, you don't put it back, so there's only 9 tickets left. But you still have 6 yellow tickets. So this is just going to be 2/5 times 2/3. So that would be 4/15. All right. The probabilities that students A, B, and C can solve a particular problem are given here respectively. If they all try, determine the probability that at least one group solves the problem. So the hard way to do it is just to do, well, let's say at least one. So if you have at least one, let's let it be the first one. All right. And then the other two would be the complement. So the complement of 2/3 means 1/3 that they can't solve it, and 1/2 is just 1/2. So that's at least one. Then you could say, or at least two, because at least it could be 1, 2, or 3. So then you do 3/5 times 2/3 times 1/2. And if you do all three solve it, that would be 3/5 times 2/3 times 1/2. So this and means or. At least 1 or 2 or 3. So this would be 1 or 2 or 3. The easiest way to do it, however, is do the probability that none do it. And you do 1 minus that. So if you find the none can do it, that would give you all the possibilities that we got here. So let's do 1 minus and the probability that none. So the complement of 3/5 is 2/5. So if student A can solve it is 3/5, the probability it can't solve it is 2/5. And then the next way, if he can't solve it, then that's going to be 1/3. And then 1/2 just goes to 1/2 again. So this is going to be 1 minus, and multiply across here, and you're going to, the 2's cancel. So you're just going to get 1 divided by 15. So this is just 15 divided by 15 minus 1 divided by 15. So that would give you 14 divided by 15. And that's at least one of the groups solve the problems. All right, next problem is our last example. Bin contains 12 identically shaped chocolates. 8 are strawberries. If 3 chocolates are selected randomly from the bin, determine that they're all strawberry. So, simultaneously means there's no replacement. So, we're doing 3, selecting 3. So, the first set would be 8 out of 12. That means no replacement. So, now we only have 11. And you have to go down 1. So, instead of 8, it's going to be 7. And then now we only have 10 chocolates and only 6 left. And then we can simplify this. Let's see if I can do this. This will go into this 2 times. You can divide both of these by 2. So that would be 2/5. Multiply across. You get 14 divided by 110. And we can simplify that further. This is 20. This is 10 times 11. So that would be 7 divided by 55. Now, we want to show that none of them are creams. So that's just going to be, none of them would be, if none of them are strawberry creams, we know that 4 aren't. So that'd be 4 out of 12 times 3 out of 11 times 2 out of 10. Now I can simplify this as 1/3 times 3/11 times 1/5. And that's going to give you, the 3's cancel. So that's going to be 1 divided by 55. And that's it. Thank you. Have a nice day. Bye-bye.